Good morning, good morning, good morning. Good job on your quiz, Danny.
Thanks.
All right, here we go. Welcome to Monday. Let me share this with you. Okay, any questions on the homework?
No.
Okay. Right, do I have the right one up? I thought it was 1 through 12. No, that was it. That was correct. Oh, okay, here we go. Here's 1 through 12. All right, no questions. Here are the answers. You will see this on the test. Questions 1 through 6. So remember when they give you two sides of a triangle and they say, what are the parameters of the third side? To find the smaller one, you simply subtract the two numbers. To find the larger one, you simply add the two numbers. So on number 1, it's going to be bigger than 3, but smaller than 15. On number 2, it's going to be bigger than 2. All I'm doing is subtracting the two numbers. And it's going to be smaller. All I'm doing is adding. Smaller than 28. So bigger than 2, smaller than 28. Number 3, bigger than 0, smaller than 200. They throw some variables in, still done the same way. It's going to be bigger than 3n, smaller than 17n. That's number 4. Number 5, it's going to be bigger than a minus b. That's just variables. And smaller than a plus b. And number 6, it's going to be bigger than 5 and smaller than 2k plus 5. On the quiz, or I'm sorry, on the test, I'll just give you two numbers. It's pretty straightforward. All right, on numbers 7 through 9, they're just asking which angle is the largest one. So you find the biggest side, you look for the angle that's opposite. So number 7, the biggest side is 13. What angle is opposite 13? Angle 2 for number 7. Number 8 is angle 1. And number 9, it is angle 3. 10 through 12, now it's asking for which side. So you find the angle that's the largest. So for number 10, the angle that's the largest would be k plus 2. Therefore, the side opposite that would be df. Number 11, which would be wt. I thought number 12 was the hardest one. So here's the explanation for those of you that struggled with number 12. You would think that the answer would be OC. It is not OC. And you're like, well, wait a minute. 10 degrees is the largest one other than that 90 degrees. So you would think that that's the triangle you should look at. Well, if you notice the triangles are constructed, the hypotenuse is always the largest side for right triangles. So each subsequent triangle is constructed from the previous one. So yes, OC is the biggest side on that first triangle, but that's not a leg of the second triangle. Therefore, the hypotenuse of the second triangle will be the largest side. And then, by the way, that's the leg of the third triangle. Long story short, it's the hypotenuse of that third triangle that's the longest side. So OA is the answer for number 12. I like number 12. That was a good question. That was a hard one. Okay. I think there's a few of you. I'm going to jump off the screen for a second to look at my grade book. A bunch of you did do the quiz. Some of you did not. Now, I'm recording this class on Monday. For those of you that are day behind, you should be doing the quiz right now. So yeah, it looks like the majority of you have not done your quiz. So like I said, I'm recording this Monday morning. So some of you are literally doing the quiz today. So that's fine. So let's just say calendar day by Tuesday, everyone should be done with the quiz. So Wednesday morning, if you're not done with the quiz by Wednesday morning, I'm putting zeros in the grade book. So just make sure you get those in. I got quizzes from Danny, Amaya, Cadence, and Jenna as of Monday morning. But some of you are watching, like I said, you're a day behind because you're watching this, watching the recordings rather than coming live. Okay. Back to this. Oh, calendar-wise, we're going to do a review tomorrow, test on Wednesday. Here we go. Homework for tonight, 1 through 8 all. The chapter actually ends on a very easy section. It is 2 weird theorems, but the understanding of them is pretty easy. The actual proof is challenging, but the understanding of them is pretty easy. 1 through 8 all. Page 231. All right, here we go. So once again, the entire chapter is on inequalities, and we're going to look once again at another flavor of inequalities and triangles. It's basically 2 theorems today, and we're going to do 2 proofs. We're going to talk about them briefly. We'll do some practice problems and call it a day. I don't think this is going to be more than a 30-minute class. All right, so I would say this one compared to the other ones are pretty easy. So I'm not going to do the proof or the demonstration because I need to do that in person. We're just going to jump right to the proof. All right, so here's the proof setup. I got 2 triangles. I mean, visually, they certainly do not look alike. But remember, we can't judge anything on a proof just by visual unless there are markings on it. So let's see on the markings. On the markings, we have 2 sides of 2 different triangles congruent to each other. So notice on triangle ABC, 2 of those sides are congruent to triangle DEF. So we got 2 sides. And notice it tells us one other thing. It tells us that the angle, in the case angle B, is way bigger than angle E. So angle B is bigger than angle E. So we don't have SAS because they're not congruent, but we do have something about the angle between the 2 congruent sides. So the included angle. What we have is an inequality. We have that this angle B is bigger than angle E. Okay. So we're trying to prove that side AC is bigger than side DF, and it kind of makes sense, right? By the way, if we were in class, the visual explanation is I would have shown you that construction of those 2 triangles. All right, so that's my given. I got to show that angle B is bigger than angle E. So the first thing I'm going to do, it's one of those proofs that it's hard to come up all by yourself, is I'm going to draw an additional line. In this case, a ray. So I'm going to draw BZ so that angle, take a look at this, angle CBZ is exactly the same as angle E. So I'm going to claim that, I'll draw this real quick. I'm going to claim that this angle right here, CBZ, is exactly the same as this angle here. So that's my basic construction, and I can do that. And why can I do that? Because we already know that angle B is bigger than angle E. So therefore, if I make angle B smaller at some point, I will get that that angle is congruent to this angle. So I'll clear all that mess up, but that's the basic construction. Okay, so we can do that by construction. I'm not claiming where point Z is, it's just somewhere. All right, but what I am claiming, and I'll leave this part up, what I am claiming is that this angle now is congruent to this angle right here. Okay. The next thing I'm going to do is I'm going to, excuse me, I'm going to put an X on BZ somewhere. I know that there is a distance, ED. I can measure that distance. And I'm going to find that distance here on BZ. Well, here's the issue, is that distance, I don't know exactly where it's going to wind up. It could wind up here, it could wind up here, or it could wind up exactly right here on AC. So there's actually two cases here. The case where this point, right, we'll call it X, where X winds up on AC or X does not wind up on AC. So we're going to consider both cases. Both cases. All right. So the first case I'll consider is that X is on AC. All right, that's the first one. So if X is on AC, clearly we got a different triangle here. And notice that triangle would give me an immediate SAS, because remember, I made BX so that it would be congruent to, I should only put one tick mark. I made it so that it would be congruent to ED. So therefore, this triangle, XBC and DEF are congruent by SAS. So if X is on AC, remember that's only case one. If X is on AC, then those two triangles, XBC or BXC, is congruent to EDF, all right? And that's by SAS. Cool. So if those two triangles are congruent, then therefore immediately we could say that XC is congruent to DF, right? Because of CP/CTC. So 1, 2, 3, 1, 2, 3. All right, well, that makes sense. But here's the issue. If that's the case, then side AC would have to be bigger than XC. Why? Because AC is the whole thing, and this is only part of the thing, part of the side, right? Well, that makes sense. That's a segment addition postulate. Okay, but wait a minute. Somewhere up here we said, oh yeah, right here, we said that XC is the same as DF. So anywhere I see a XC, I can write a DF, so I will write a DF using substitution, and we got what we needed. So we got to our very end, which was AC is bigger than DF. Okay, so just a little bit of substitution. So there's case one, that's if X is on AC. So clearly, if that's the case, then AC has to be bigger than DF. Now there is one other case, and that's the case where X would not be on AC. It could either be inside or it could be outside, right? X could be there or it could be there. And that's case number 2. Now, our book actually does that proof. It takes almost triple the amount of steps to prove that as it did to do this one. Remember, I choose occasionally not to show you a proof. It is in the book with the reasons behind it. It is on page, flipping here real quickly. It is on the bottom of page 228. It's called case 2. So if you're curious and you want to see why you get to the same reason for that one, by all means, flip to the bottom of that page and you're free to check that out. I'm not going to do that one in class. I'm just going to say check the book for it. Okay, so we basically proved through 2 different cases. Remember the second one I didn't show you. Through 2 different cases that if you have a triangle where 2 sides of one triangle are congruent to 2 sides of the other, and you can say something about the included angle, that one angle is bigger than the other, it must be the included angle, that therefore the opposite side to the larger angle is the larger than the other side. And we're going to write this down. This is Theorem 6.5. They call it not the SAS congruency, they call it the SAS inequality. So it basically says this. That's a lot of words, but what it basically says, that if you have 2 triangles where you have 2 sides of one triangle congruent to 2 sides of a second triangle, and further, that you can say that the included angle of one of the triangles is bigger than the second one, then if you want to look at the third sides of both triangles, the side opposite the larger, in other words, the side opposite angle B, and that's AC, must be bigger than DF. AC must be bigger than DF. And it looks like, I mean, that's a lot of words to copy down in your book of truth, but the reality is it's a pretty simple one. If you have 2 sides of one triangle congruent to 2 sides of another, and the included angle of both of those triangles between the 2 congruent sides, one is bigger than the other, and the side opposite the bigger angle is the largest of the 2 triangles. And that's what it says. Yeah, I got to be careful with the last thing I said was that therefore the side opposite the larger angle is the largest of the two triangles. Well, compared to those two sides. So I don't know if AC is bigger than AB or BC. I don't know that. But I do know that compared between the two triangles, that AC is bigger than DF. There, I said it accurately that time. Let's see, who's live here? Just Danny and Chris. So Danny and Chris, when you get this copied down, give me a thumbs up so I can move on. Chris, I didn't get your quiz back yet. You're doing your quiz? You can stop drawing at any point. All right, we good, guys?
Yeah.
Okay. I said it was an easy day. So once again, they're going to give you two triangles. There's going to be two sides that are congruent. They're going to say something about the angle in between, and they're going to say which side is the largest. So all you do is you pick the angle that's the biggest one, and the side opposite is the biggest side. Now remember, all I'm saying is between AC and DF, which one is largest. Okay. So the next one more proof, and we're done. Quick class today. Looks like the same thing. Look, we got two sides of one triangle congruent to two sides of the other. This time we're not going to say something about their angles. We're saying something about their sides. So it's the converse, right? So we're going to say that AC is bigger than DF. AC is bigger than DF. All right. We're trying to prove now the converse to that the angle opposite the larger side is the larger angle. Okay, so it starts off the same way, and we're going to do that same trick. We're going to draw a different or an auxiliary line. All right, so we're going to do this by a proof by contradiction. It turns out it's pretty easy by a proof by contradiction. And by the way, on the test, the one proof will be a proof by contradiction. So this gives us a chance one last time to look at proof by contradiction. When you do a proof by contradiction, what you do, once you declare that you're doing a proof by contradiction, so you write the given, and your very next step is by contradiction, you take the prove and you negate it. Well, if measure of angle B is greater than angle E, well, to negate that, I would say it's not. Now, unfortunately, this brings up two cases. That means it's either equal or it's less than. If it's not greater than, then it's either equal or it's less than. So proof by contradiction, you're going to see how easy this one is by a proof by contradiction. So we'll do it one case at a time, and it doesn't matter which case you do first. So case number one, we're going to consider that angle B is equal to angle E. Because remember, if we're trying to do a proof by contradiction, we take whatever the proof is and we negate it, and then we show that that's going to lead to some contradiction. If it's not equal, then it must be either less than or greater than. All right, let's see what happens if we make angle B equal to angle E. So if we make angle B equal to angle E, that means that they're congruent. Well, if you notice, immediately we got an SAS. And if we have an SAS, well, then that means that this side by CPCTC is congruent to that side, and that can't be true because in the given it says that AC is bigger. So the reason why we can't prove that, or case number 1 is false, is because it would make the two triangles congruent. And if the two triangles are congruent, then CPCTC would say that AC is congruent to DF. And that can't happen because of the given. So all those words right there are what I basically said. So if angle B is congruent to angle E, that means their measurements are equal. Therefore, the two triangles are congruent by SAS. Therefore, AC is equal to DF, and that contradicts our given. So that's not the case, right? Case number 2 would be that, therefore, maybe it's less than. Remember, by our contradiction, by this statement right here, we're claiming that angle B is not greater than angle E. There's two possibilities. That means it's either equal or it's less than. Well, we just proved that equal didn't work. We got to show that less than doesn't work. All right, let's see what happens if they're less than. If angle B is smaller than angle E, immediately, remember, we have that one theorem that says, therefore, if you have two triangles, right, the previous one, two triangles where you have two sides and you can say something about the included angle, this is the previous theorem, that the side that's opposite the larger angle is the larger side. So let's see, what would be the larger side if angle B is smaller than angle E? So if angle B is smaller than angle E, then this side would have to be the largest side. And once again, well, that contradicts what we're given in the given. So that can't happen. Why? Because if angle E is the larger, that's what we're claiming right here in case 2, that B is smaller than E, right? Therefore, by the SAS inequality theorem, then therefore DF must be the larger of the two. And that contradicts the fact that in the given, you're told that AC is larger than DF. So that didn't work either. So if angle B is not equal, if it's not less than, there's only one other possibility, that B must be bigger than angle E, because I disproved all the other possible cases. So here's an example where literally a proof by, now granted, we filled up this whole paper, but the nice thing was that the logic behind it was clear and simple. All right, the reason why that it must be that angle B is larger than angle E. So this was the converse to the previous one, and this is called the 6.6, the SSS Inequality Theorem. And the SSS Inequality Theorem says this: if you have two triangles where two sides are congruent to two sides, and you can say something about the third side, right? AC is bigger than DF, then you're allowed to say that angle B must be bigger than angle E, because we're told that AC is bigger, greater than DF, right? And this is why it's called SSS, because the blue part, we're given something about all three sides. The previous one, the SAS inequality theorem, we're given something about two sides and the included angle. So even though I don't have a third tick mark here for the third side, it's still called the SSS inequality because of this statement right here. So I got one side, two side, three side. That's why it's called SSS inequality. So what does it say? If you got two sides of one triangle congruent to two sides of the other, and you can say something about their third sides in an inequality, then therefore the angle that's opposite that third side that you're saying something about with an inequality has to be the largest one. Which one's larger? AC is the larger. Look at the angle that's opposite AC, this angle right here, angle B. Therefore, angle B must be larger than angle E. And that's what it says. All right, once again, I'll give you time to write this down. And we'll do a couple of examples. We should be done around 35 minutes of class time. Still waiting on a response from you, Chris. You're going to do your quiz?
Yes.
Excellent. We good?
Yeah.
Okay, so how can I use this? I'm going to give you some examples here. So we have a shape right here. Clearly there are two triangles here. And we're told a couple things. Let's see, what are we told? We're told that RS is congruent to RT. We're told that angle 1 is bigger than angle 2, and by reflexive property, right, we have that RV is congruent to RV. So I got an S, I got an S, and we're told something about an angle. So I have an SAS inequality. Chris, if 1 is bigger than 2, then which side is bigger, SV or VT?
SV.
That's as easy as it gets, right? Danny, did you follow that logic?
Yeah.
Yeah, pretty easy. Pretty easy. Okay, this one's for you, Danny. It's colored. Whenever you see colored shape, that means this is a 3D shape. So you got like a paper airplane standing on top of a desk right on its edges right here. So tonight for homework, I think there are no 3D ones tonight for homework. Okay, so here's what it says, Danny. It says that it says that EF is congruent to FG. So EF is congruent to FG. We got this reflexive property right here that's shared between the two triangles. And this time it doesn't say something about the angles, it says something about the side. It says that DF, I'll make it really dark, is larger than DG. So I got SSS. So this is the SSS inequality. So therefore, which angle, and I'll label this 1 and I'll label this angle 2. So which angle is bigger, angle 1 or angle 2, Danny?
Angle 1.
That's all there is saying, right? Pretty simple. If only all the sections of geometry would be like this, I'd have a whole bunch of people that would make A's, but that's not always the case. All right. Very good. A couple quick ones. We'll start off with Chris. You take a look at it. It says, what can you deduce? Name the theorem. I don't need that. I just need you to tell me which angle is bigger. Angle A or angle D, Chris? Number 1.
Angle A.
Pretty simple. Danny, look at number 2. I don't need you to tell me what can you deduce or the theorem. I just need you to tell me which side is bigger, JK or NO?
NO.
All right, you guys got this?
Yeah.
Yeah, there's nothing challenging about this. Now, a couple times, look at number 3. Occasionally, you will get something where there's a shared side. Just remember reflexive property. Therefore, Chris, which side is bigger, RT or ST?
What was the question again?
Which side is bigger, RT or ST?
RT.
Yeah, and I just want to make sure that you're not visually looking at it. In other words, like, well, it looks like it's bigger. The logic behind it is it's bigger because angle 1 is bigger than angle 2. So that's the reason, or that's what you can claim. And by the way, the proof for this would have been SAS Inequality theorem. All right. Any other questions, guys? You got a handle on this?
Yes.
Yeah, I'm good.
I think so too. And like I said, I thought that of many of the ones, today's class was probably one of the easier ones. All right, that's all I had for you guys. That was your homework. In case you weren't there to copy it down, 1 through 8 all. If you run into any problems, send me a chat, right? Send me an email. I'll be happy. Chris is going to take his quiz. Danny's already taken his quiz. And for everyone else listening, you're going to take your quiz. If I don't have results by Wednesday morning, I'm turning those results into zeros. All right. Well, that's a bad way to end class. All you guys are going to pass because it's an easy quiz, and you're going to do fine on it, and you're going to raise your grades. There we go. We ended on a good note. Review tomorrow. Tomorrow will be a very quick class. I'm going to basically just open it up to questions, and I'll say, all right, that's all we got. The practice test will be posted in the morning. The practice test will be a very similar to the real test. Obviously, there will be a proof by contradiction. So for those of you that need help, show up tomorrow live, and then I'll give you some live help or whatnot. If you don't need help and you look it over and you're like, I got this, then enjoy. And then Wednesday we will take the test. We will not have a class on test day. It'll just get posted at 7 o'clock in the morning. You got the entire day to take the test on Wednesday. So that's it for me. You guys have a wonderful Monday, and I'll see you tomorrow morning. Later.